Good morning, everybody. All right, we're live. Oh, I'll just record this, and if you don't see it, well, whatever. It will be recorded so you guys can see it. I'm just gonna talk a little bit about everyone's content, fifth, sixth, seven, and eight. Um, I said it before. I'm gonna do something for May the Fourth be with you. So for seven and eighth grade, the reason why your assessments is not due till Tuesday instead of Monday, which is 2 days. That's why. No spoilers, please, for the new Star Wars or Clone Wars. I already know it. It had to happen. He's got to do it to them. But yeah, we'll do Star Wars related stuff on Monday. It'll be fun. I can guarantee you, man. Oh, we got someone here on live stream. Hi, one person. All right. So what I'm going to cover today is first. Let's go with fifth grade stuff. You guys are going to be starting the next chapter. These are all short. I think physics is the next longest one, but even then, I think each week we'll have like a week or two. We'll have a brand new chapter. But today we're going to cover basically minerals, and the rock cycle. First, minerals. First off, what's a mineral? Minerals make rocks. They're the basic unit of building blocks when it comes to materials made on Earth, like rocks and stuff. Minerals are the basic form. Minerals are made up of chemical compounds, which we'll talk about in sixth grade. Sixth grade, you know what chemical compounds are. We'll do that. On your textbooks, I'll only cover a few things from the textbook. That includes what a mineral is and some testing, because you could test different. And when you go to high school and college, you'll have to test different types of minerals. And one of the tests you have to do is the hardness scale. The Mohs hardness scale. Now, with the hardness scale, it's labeled 1 to 10. 1 being the weakest, you could easily, and this is a special thing. There's a difference between breaking and scratching. Just to see how strong it is, how strong to scratching it is. So, for example, I scratch my fingernail, it's not that strong. With the rock scratch or the mineral rock scratches my fingernail, well, obviously that must be super strong. Because sometimes you think like, oh, I could break that mineral in half with my bare hands. Yeah, but it rubs with another one, maybe it's stronger. It's labeled 1 through 10. With 1, ignore the crazy noise upstairs. There's a lot of all my family's here. All 7 of us. And the dog. The dog, I think, is downstairs or upstairs sleeping. I don't know where. But most hardness skills is leveled 1 through 10, with 1 being the weakest, 10 being the strongest. Easy number 1, talc. Thing that when you were a baby, your mom, whenever you had to get your diaper changed and clean it up, talc powder. The reason why it's so easy and simple and doesn't hurt your bun is because it's really weak. It's not that strong. You can break it easily. You can break it and make into makeups and stuff. Our fingernails can rip up to 6 or 7. 7 is quartz, which is a really common mineral you'll find everywhere. And one of the more hardest and most difficult minerals to break is diamond. Yay! Minecraft was right all along. You can still break diamond, like with a hammer, sledgehammer, but when it comes to like cutting it, the only thing a diamond can cut by is a diamond. Yes, that's right, boys and girls. Jewelers use something called a diamond buzzsaw and diamond tip tools because that helps them scratch the diamond and make it to the size of my finger or whatever shape you want. There's another property in luster. Luster is basically how it looks. Is it shiny? Is it dull and look clayish? There's many properties, but basically it's how light reflects. Sometimes it looks metallic, a piece of metal, and like it looks metalish, Mr. Robles, or it looks shiny or gold, or it looks dull like pearl or some clay. Well, usually, or it looks earthy, like it looks like a piece of dirt, but it's not dirt. It's a mineral. There's many different types. There's glass. Once you go to high school, you'll memorize them. I'm not gonna make you memorize them as long as you give me a proper description of it. This luster, like it looks metallic, it's glassy, it's shiny, metallic, etc. I'll give it to you. Excuse me. Another unique property is now here's a good thing. A lot of people would say, "Oh my goodness, I can tell property. It's the color of the mineral." Yes and no. Color, yeah, it can help, but a diamond can be any color. That's the problem. And usually, the colors of a mineral depend on what's inside of it. Sometimes, for example, pure quartz diamond should be clear, but quartz can be found in many different colors. That's because it's been contaminated with other minerals or other elements in there, and that's why it changes its color. That's why color is not always proper. And if I was in my classroom, I would pull up my two minerals that they look the same, but they're technically one's quartz, one's not. One's calcite. They look the same color, but they're not. They're different properties. An easy way though for color to distinguish is by scratching the rock. If you scratch it against a tile, piece of tile, special type of ceramic, it creates a special dust color. Now, that is technically all unique. Every element, every mineral has a unique color. Sometimes they repeat colors, but that's one way you can tell the difference between, like, for example, if I were to scratch calcite and a quartz, calcite will be pure white, while quartz might be more dull, crystal clear. But yeah, that's the one thing. Another thing, because also if you another famous example of don't trust color, the mineral is pyrite and gold. Pyrite looks exactly like gold. It looks exactly the same. The two exceptions are it smells, which could be a property, but there's only a few minerals that smell. But the main difference is pyrite, when you scratch it on ceramic, it's green. Of gold does not scratch is gold. So you can tell the difference. Pyrite is used for a lot of stinky stuff, a lot of like chemicals that they put for like pesticides and stuff to scare people away. Also used for fires. That's why it has the word pyrite, pyro. Another thing is it's basically it's ceridium, or how the crystals inside look like. We're not going to talk about that much because it's a little bit difficult. The only one I could use an example in classroom would be graphite and diamond. Graphite is more like sheets. All the elements are holding together, and this is for sixth grade. All the elements are holding together like a polymer, just straight. While diamond is more of a ring with polymers, where basically the structure actually looks like a diamond if you look microscopically. How do we know that? A lot of math. When you go to college and you take a geology class, like mineralogy, like I did, you get to see it in the microscope, under an electric microscope. It is insanely beautiful looking, but at the same time, oh my goodness, it's so difficult. Hi, it's me. Hi, cup of nothing. That's the username for the recording. Yeah, I'm recording today in the afternoon. I have technical difficulties in the morning. I tried to record in the morning, but it's nothing was going on there, and that was weird. I'm like, oh, let me retry. And I had a meeting, so couldn't do it. But yeah, that's mostly with the properties of color. Fractures, basically how a mineral breaks apart. Yeah, I remember you. Don't worry. Basically, when you break a rock, it can shatter into different shapes. For example, mica. I have a couple mica pieces at school. They tend to break like a sheet of paper for some reason. Even if I crack it on the side, it'll still break like a piece of paper. While calcite would break into cubes. It's weird. Cleavage is how it's structured. Like, is it parallel, even, or is it like uneven shaped? Stuff like that. But yeah, that's pretty much everything for fifth grade. We'll cover a little bit more later. Hi, other person that just arrived. I'm going to start talking about sixth grade. Yeah, I'm live. I've been live for a couple. Well, not today, but I've been live for a couple of days. Like, yeah, my tub of popcorn is about to end. I feel sad. Oh well. I was gonna use this for class eventually, but can't use it anymore. It was bigger. You should have seen the thumbnail of a few days ago. And it was bigger before then. Yeah. Give me popcorn. You're never awake. Yeah, you should get the habit of waking up. You're how many months away from high school? Anyway, I'm gonna go quickly over nuclear reactions. Hey, that's sixth grade talking about. Yeah, nuclear reactions. Oh boy, this one I might give you 2 days to do the actual notes, because there's so much to talk about. Like, I don't want to go over every little detail because it's way too complex. But yeah, nuclear reactions. Basically, it's a method. It's different from normal chemical reactions. The main difference is atoms split. Atoms are split or merging, one of the two. With nuclear, there's two versions: nuclear fusion and nuclear fission. Fusion is basically two molecules get shot at a super high speed, and then causes them to merge, and that merger creates a little bit of energy, or a lot of energy, Fusion does a similar, but not that much. Energy is basically breaking up heavy atom half. Anything above uranium, you can break. You stop fighting in the commie chicken. Someone left. No. One of the easiest ways to figure out how much energy has been gained or lost is the famous equation of E equals mc squared by Isaac Newton. E basically stands for energy, M is mass, C is the speed of light. So basically, you have to go super fast, or the energy has to travel super fast, in order to actually cause it to merge and create the new product. Isotopes are basically unstable. How can I say molecules? They need, or not unstable, but basically they're not the norm, like an isotope, pretty much from the previous section. There's two versions of fusion, and that's through radioactive energy. Radioactive energy is basically anything that's constantly breaking apart. Alpha decay. Yeah, but we're going to use uranium for this example. Uranium breaks into radon and an alpha particle, or basically helium with some energy here left behind. Usually that really is the most energy, but it's kind of hard to pull off. The more common one is beta decay, and that's used for nuclear reactors. That breaks off the like how could I say this? Let's take carbon. The example in the book, carbon. Carbon breaks, releases energy, just like alpha. But in that case, it releases a nitrogen molecule and a beta particle, which is just a neutron, plain neutron. That plain neutron is going so fast, it can shoot others and start a chain reaction, and you know the rest. Radioactive decay, like each level creates a certain amount of energy, like usually it's gamma particles, and that can go through almost everything except for concrete and lead. Concrete, it has to be a certain layer of concrete, if I remember correctly, because, like, for example, Chernobyl, they recently made a dome. I mean, it's like a good, I forgot how many meters thick of concrete to cover the whole area, but yeah. We'll talk a little bit more about its uses and also factory uses as well, because you will have to know for an assessment later on how a nuclear reactor functions. And if we were still here, we would play the nuclear reactor game. I don't know. I might make you play the nuclear reactor and screenshot your high score. But yeah, that's everything for nuclear reactor. And let me finish off some of the main theory, because they have exercise. Physical fitness, as I said before, you have to exercise daily, man. Daily, man. Or else you'll be a chubby man like I am. Or Winnie the Pooh. Well, basically, when it comes to exercising, make sure you're always doing a little bit of both aerobic exercises. Anaerobic is you're stationary. You're not moving that much. Like maybe you're moving your arms when it comes to bench presses or deadlifts. But anaerobic requires the whole body moving. So swimming, running, soccer, stuff like that, sports. You have to do a little balance of each. Like anaerobic specifically targets area of the body, while aerobic targets everything. Oh yeah, I did. Are you helping her with work? How dare you? There's different types of exercise. You'll have a project sometime next week before we move on to book A, which will cover basically different types of exercise, like cardiovascular, cardio, that works with the heart, respiratory, muscle training, stuff like that. If you remember what I talked about when it comes to weightlifting, depending on whether you want to make muscle tone or muscle mass, you can make, like, you have to decide. Like tone, you don't work out that much, but you do, or you work out a lot, but you're not too much, like strength wise. Strength, you work at your max strength, but not that much. And no, you can't do max on both. Your body will die. You exaggerate yourself. Oh ho ho! I think that's the sound effect that Amazon has arrived. Man, I feel like Blue's Clues. I'm gonna start saying like, I wonder who that is. But yeah. Oh, we got someone back, and they came at the very end of my stream. I was playing this earlier, so. I'm gonna end the stream. I think I covered everything. There's nothing else for me to cover because no one wants to interact with Mr. Robles. Man, this is the most chatty my chat has been. I should be doing this in the afternoon instead of morning, but I don't know. I'll think about it. Anywho, I'm gonna end the stream. Any repeats? Go right ahead. Be my guest. See ya.